Hey guys, welcome to my second Swift Playground video blog. So, in the continued exploration of the Swift language, I'm going to look at some more basics here. So, what we're going to talk about in this video is something called data types and data type conversion. We used to call that casting in Java. Okay, this is all gibberish too. You're going to learn about it in a second. So, before I get into it, in computer programming, there's this concept of a data type. A piece of data could be a number, it could be an integer like 67, or it could be a float like like you use in dollar calculations where you have a decimal point. It could be a string, like a string of text, like Stefan is learning, as we see here on the screen. So in some programming languages like PHP and JavaScript, they basically take care of all this data type stuff for you. It's all handled in the background. So you can do all kinds of stuff with all your data in PHP and not have to explicitly handle data conversions. You see, you can't mix and match data in certain programming languages. Java is one of them, and it seems that Swift is another. Although Swift finds a nice compromise, and I'm going to get into that in a second. So why doesn't Swift do automatic data type handling for you? It has to do with speed. The less decisions that a computer programming language has to make, the faster it can compute. So they found a nice middle ground here with Swift. So let's just get into a few examples and this will all become clear. So here, we'll start with this constant I declared. Maybe I didn't mention it. The keyword let is the keyword in Swift to create a constant. You got constants, you got variables. Var is for variable. The difference between a constant and a variable is that in the variable you can change the data in your program. You can change the value. So for instance, in this variable I have no Ruby and I've given it a value, which is a string, and we know it's a string because it's in these quotes here. Right here, excuse me. So this could change with programming. I may change what the string is along the way. Whereas when you have a constant like let, it's fixed in terms of your program. And there are efficiency reasons for it and data integrity reasons for using a constant rather than a variable, but we won't get into that right now. So let's jump down to our constants here, because that's where I'm doing all this data type manipulation, excuse me. So first of all, I declared a constant. It's called an int, and I just gave it the value of 67. And of course, the playground gives us our interactive response here and says, okay, 67, that's cool. So this is where the compromise in Swift comes into play. See, at this point, I didn't explicitly tell Swift that this was an integer, but because it was really obvious to it, it knows that it's an integer and it didn't give us an error. So let's look at another type of number, and that's a double. Now in this situation, I declared that explicitly that this value here was a double. And let me just get rid of this error here because it's screwing up my display. Okay, so there we go. So you see here, let explicit double. So the name of this constant is explicit double. I use this little colon here, and that's code that tells Swift that we're going to make this particular value here a double. And you see it's a double because you see you got a period 0. Now, and you tell it it's a double by using the double keyword. Now, if I would use the int keyword, watch what happens interactive. See, it becomes 70 without the 0. So I go back, I go double. And you see we got 70. So you see how Swift is compromising here. Sometimes you can make it a double explicitly. Sometimes you don't have to declare it. But if I don't declare it, if I just go like this, it's just going to assume that it's an int. There's no way for Swift to know that this is a double. So that's where declaring things explicitly in terms of your data types comes into play. Let's move down here. So here we go. I explicitly set this to a string. I didn't have to, right? But I did. So I could have just as easily done this, and it's still going to be seen as a string. So now let's look at a couple of errors. So, well, not a couple of errors. Let's look at how we can combine one data type with another data type. So in this situation, I got my variable explicit double, and explicit double is, well, in this case it's not a double because we declared it int here. So let me just make it a double. See if it figures it out. Yeah, there we go. So now it sees it. It's probably going to see this as a double because it sees the period. So let's say we got our variable double, explicit double, and in this particular situation here, we're adding it to our string, explicit string. Now, what I've done to make it work, if I use this method here, string, and this basically converts this double into a string, right? So it works very good. Now, let's look at this interactive capability. I'm just going to add some spaces and watch how the spaces are reflected in our new constant called together. Yeah, so let's go back a couple spaces. So let's take off this casting, this conversion, and you see we got an error. Now we click on the error. Could not find the overload for the positive symbol, the addition, that accepts the supplied argument. So basically, I won't get into overload now. See, that's an error because it's not able to combine them. Of course, it displays it properly. You know, Stefan, well, not properly, just displays one after another, because if you look here, see, it doesn't display the space. So it's very friendly enough, the playground, to just display the value of explicit string right afterwards. But you see there's no space here. Now if I go back and I convert explicit double to a string so that we don't get our error, so it actually does the adding together of the of our constants, all of a sudden you see it works. See, the space is now reflected that we have here in this new constant together. So there you go. You've learned a little bit about data types, data type conversions, and how Swift compromises in that regard.